Hi everyone. So today we'll be going through review exercise one. Okay, so I'll do question one, but not all the parts lah. Okay, so um okay, let's solve. Okay, so solve each of the following equations by completing the square. All right. So that means we are going to we got to transform. Change the equation to the completed square form before we solve, right? So first thing I'm going to do question 1D. Okay, so question 1D. Yep. So for 1D, right? So x squared plus 1.2x equals to 1, right? So x squared plus 1.2x, then I bring over the 1. So minus 1 equals to 0. And after that, I try to do completing the square. So plus 1.2x plus 0.6 square. So how I get 0.6? Because 1.2 divided by 2, right? Then minus 1 minus 0.6 square equals to 0. Equals to 0. So this part here, you can complete the square, and then it becomes this x plus 0.6, the whole thing square. And then for the other part, this part here, we will press the calculator. So I will get minus 1.36 equals to 0. Okay, so x plus 0.6 square equals to 1.36. X plus 0.6 equals to plus minus square root 1.36. So x equals to negative 0.6 plus minus square root 1.36. So x equals to negative 0.6 plus square root 1.36, or x equals to negative 0.6 minus square root 1.36. Then solve, right, using the calculator. So on the left is 0.56619, round off for 3SF 0.566. Okay, 3SF. Then the other part is change, it's the minus lah. So negative 1.76619, 3SF, negative 1.77. Okay, 3SF. All right, so this is question 1D. Okay, and this is it for question 1. Okay, hi guys, let's do question 2 together. So solve each of the following equations using the quadratic formula. So just going to do one part as well. So maybe we will try question 2C. Okay, so 2C, negative 4x squared plus x plus 5 equals to 0. So coefficient of x squared is a lah, negative 4. Coefficient of x is 1, which is our b. And lastly, c, the constant, so 5. So x equals to negative b plus minus square root b squared minus 4 times a times c, right, over 2a. Okay, so if you simplify the cert, right, I mean the numbers in the square root, you will have 1 plus 81, right, over negative 8. Oh, nice, 81. So means it's 9 inside lah. Wait, is it 81? Oh, it's not 81. It's 79. Yeah, because 4 times 4, 16, 16 times 5, 80, then 1 minus 80 is 79. It's not 7. I do the. Wait, it's 81. Okay, I think I better press the calculator, but I think it should be 81 because the minus give you plus. Yeah, 81. Okay. Yeah, so my bad. So it's 81. So equals 1 plus minus 3, 9, sorry. 1 plus minus 9 over negative 8. So x is equals to 10 over negative 8, or x equals to negative 8 over negative 8, which is 1. And this one is negative 5 over 4. Okay, let me take a look to see whether if I got any other careless mistakes. Oh, there is. So sorry, there's a careless mistake over here. So it's a negative here. Yeah. Okay, so negative and then negative lah. All right. So that means it should be negative 1 plus 9. So 8 over negative 8 or -1 minus 9. So -10. Ah, okay, great. -10 over -8, yes. Okay, then this one should be -1. Okay, so sorry, a bit sleepy after lunch. So this -1, then this is 5 over 4. Okay, yes, so this is the answer for question 2C. Okay, guys, I will go through question 3C, right? 3C. So for 3C, right, I will have to expand everything and then bring the 9 to the left. So x squared, right? Then plus 3x minus 3 minus 9 equals to 0. So x squared plus 2x minus 12 equals to 0. Okay, then after that yeah, I mean in this case you can do completing the square or quadratic formula lah, but I prefer quadratic formula because it's way faster. So x equals to -b plus minus square root b squared minus 4 times a times c, right, over 2a. So this is equals to -2 plus minus square root 4 plus 48. 4 plus 48, 52, right, over 2. Okay, so then my x will be equals to, so just got to calculate lah, right? So 2.60555, round off 2.61. This is 3SF. Okay, then the other one is, oh no, yeah. The other one is -4.60555, right? Round off, -4.613SF. Okay, yeah. So I think in this case, using the quadratic formula is way faster than completing the square. But if you wish to do completing the square, it's nothing wrong as well lah. Okay, can. Oh yeah, one thing to take note, I have some students who were saying, can they do this? Like x minus 1, x plus 3 equals to 9. No, as in like, this is the question. Then they say x minus 1 equals to 9 or x plus 3 equals to 9. This doesn't apply here. Okay, you got to equal it to 0 first before you can, like, one bracket equals to 0 or the other bracket equals to 0. Okay, it does not work when you have a equals to 9 or any other number here. Okay, if you have some number like this question 3C, right, you got to expand the stuff, the expression on the left, bring over the 9, and then simplify and change it to a brand new quadratic equation. Then you do quadratic formula. Okay, you can't do whatever I have written on black ink. All right, okay, so this is it for question 3C. Okay, hi everyone. So today, so next one is question 4 lah. So question 4, solve the equation, blah, 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 giving your answer correct to 2 decimal places. So they didn't say how they want to solve it lah. So I am probably going to do, quadratic formula again, right? So quadratic formula, so because they didn't mention, right? So 2x squared minus 7x plus 4 equals to 0. So x equals to -b, right? Plus minus square root b squared minus 4ac. Okay? Over 2a. All right, so this will be 7 plus minus square root 49 minus 32. Right? Yep, 17. Okay, and then over 4. All right, so my x is equals to 7 plus square root 17 over 4, which is equal. Okay, let me just key in square root 17 over 4. This is 2.780776. So 2 dB. Okay, 2 dB, that's what they want. So 2.78, 2 dP. Okay, then for the other one is the 7 minus square root 17 over 4. Okay, so this one, let me just do a quick calculation, and 0.719223. Okay, so round up 2 dB, 0.71, no, 72 actually. Yeah. Okay, so 2 dB. All right, so that is for part 1, for part 1. All right, next one for part 2, right? Okay, so there's a hence question. So hence, right? Find the values of y that satisfy the equation. Okay, so if you look closely, this, right, is actually very similar to this. Okay, what happened is if we replace, okay, so you got to look at the similarity between the two equations lah. So first thing first, you will replace x with y minus 1. Okay, so if you replace x with y minus 1, right, from the original equation, okay, so original from part 1, right? So, okay, from part 1, right, 2x squared minus 7x plus 4 equal to 0, right? So when you replace x with y minus 1, so then you will have this. Right? So that is exactly what they want here. Right? So what we do, that means we also got to replace the answer lah, with y minus 1. So that means I can say, right, therefore, y minus 1 is equals to 2.780776, or y minus 1 is equals to 0.719223. Okay, so my y will just be, 2.780 what, this one plus 1. So it's 3.78, okay, 2dp. And then for this one, it's just y equals to 1.7, equals to 1.72. Okay, and then this is 2dp as well. Okay, can. So this is it for part 2. Just need to take note lah, you are comparing, okay, you are comparing the old equation and the one that they have given you. Okay, so your goal is to look at the common things between them and then try to replace, the things that is given in the new equation, right? So you have to try your best to replace stuff. Yeah, sometimes it's not that straightforward like this question, but you still got to try lah. And that is the hence part long. So if let's say I got question, people say, oh, if hence, then as usual, I didn't do the hence lah, right? I try to, expand all this out and then solve my own way in order to get my y value. Does it work? Yes, technically it works, but because they say hence, right? So that means you got to use your part 1 to do it. So they will not be able to award you any marks because you did not do the hence. Okay? Can? So just take note lah. If you really have no idea, right, then I suggest you just skip and go to the next question, but remember to come back to do it lah. Okay, can. So this is it for question 4. Okay, guys, let's do question 6 together. I think mainly I'll be doing 6G and 6H lah. Okay, not too many questions. Maybe 6F. Okay, I think I'll do 6F and 6H. Yeah. Okay, so 6. Oh no. Okay, hold on. So 6F, 6F, and 6H lah. Okay, so 6F first lah. So 6F. Okay, I will combine this. There's actually many ways of doing it. I will combine these two fractions first together. So multiply the denominator for each other. So I have this. Okay, I actually make them same denominator and then I combine them together in one single step. Okay, then after that, just simplify it. So 6x plus 1 over 5x plus 5, right, equals to 3 over x minus 2. Okay, can then cross multiply long. So 6x plus 1 times x minus 2 equals to 3 bracket 5x plus 5 lah. Okay, so just expand. So 6x squared minus 12x plus x minus 2 equals to 15x plus 15. Okay, so 6x squared minus 26 actually. 26x. Yeah. Okay, then minus 17 equals to 0. Okay, then after that, solve using quadratic formula. So, okay, let me write here lah. So x equals to negative b, right? Plus minus square root b squared minus 4ac, okay, over 2a. Okay, so let me just solve it lah. So this is 26 plus minus square root 1084 over 12. Okay, so x equals to 4.91034. 3SF is just 4.91. Okay, or x equals to the minus, so negative 0.57701. So round up, negative 0.577. Okay, 3SF. Yeah. Okay, so this is for 6F. Okay, so now let's move on to 6H lah. So 6H over here. So 6H, right? I need to factorize this denominator. Okay, I will not recommend to just multiply the denominator to each other because this is way too big. When not too big in that per se lah. It's just because if you multiply, it will be cube, right? So it's we didn't really learn how to do solving cubic equation in Emath lah. Okay, we'll be doing that in Emath instead. So for now, I can try to factorize this. So when I try to factorize this, right, it will be, wait, it will be x minus 3 and then 2x plus 1, okay, equals to, okay, I think, okay, no space, but yeah, you know what I mean, equals to 2. So that means, you see, now the left fraction, right? The denominator is just 2x plus 1. So, and it's a bit, how different is it? It's just the x minus 3 missing law. So I just times x minus 3 to this denominator and this numerator, right? So I have x minus 3 plus x plus 3 over just x minus 3 and then 2x plus 1 equals to 2 over 1. Okay, so simplify the top. Okay, I don't really need to simplify that. The top is just 2x, right? So let's just do cross multiplication, right? Cross multiplication. So it's just 2x equals to 2 bracket x minus 3 times 2x plus 1. Okay, so simplify, right? 2 bracket x 2x squared plus x minus 6x minus 3. Okay, so 2x equals to 4x squared minus 10x minus 6. Is that so? Wait a minute, let me just check. Yeah. Okay, so 4x squared minus 10x minus 12. No, not minus 10x, minus 12x. Okay, minus 6 equals to 0. So factorize out 2 and divide over. So I will be left with 2x squared minus 6x minus 3 equals to 0. Okay, then this one same thing lah. You can just do quadratic formula law. Oh. Okay, so yeah, so x equals to negative b, right? Plus minus square root b square minus 4ac over 2a. Okay, so wait, let me solve it. Okay, I'll just solve and straight away write the answer. So x equals to 3.43649. Okay, and then this is 3.44. Okay, 3SF or x equals to, let me see. Okay, negative 0.43649. Then you round up 3SF, negative 0.436. Okay, 3SF. Yeah. All right. Okay. Yes. So this is it for question 6F and 6H. Okay, guys. I'll be going through question 7. So question 7, I think, is one of the last few graphs that I'm going to sketch for this chapter lah. I sketched way too many graphs already. Okay, and I hope by now you all should know how to do it lah. Okay, anyway, so basically, right, yeah, so they want us to transform this equation into terms of factorized form. Okay, so basically is this thing over here lah. We can do this. Wait, negative 7x. Okay, so x and x. Then for this one, probably it's just 4 and 3. Okay, same both negative. So that means it's just negative 3x and then negative 4x. Okay. So that means, right, y equals to x, oh yeah, 7 part 1. Okay, so y equals to x squared minus 7x plus 12, right? And this can be factorized to become x minus 4 and then x minus 3. Okay, oh, maybe I should shift this below so that I can have more space to draw later. Yeah. Okay, so this is 7 part 1. All right. Okay, let's move on to 7 part 2. 7 part 2 in black lah. So hence sketch the graph. Okay, so let's sketch this, which means sketch this lah. So remember, first thing first, smiley or set. So this is a smiley face. Why? Because the coefficient of x squared is positive, so smiley face. Second, x-intercept, right? So what is the x-intercept? Sub y equals to 0, right? So that means x minus 4, x minus 3 equals to 0, x minus 4 equals to 0, or x minus 3 equals to 0. So x equals to 4, x equals to 3. Okay? Then info number 3, y-intercept. Okay, so y-intercept means sub x equals to 0 lah, right? So y equals to 0 minus 4 and then 0 minus 3. So it's just negative 4 times negative 3, which is 12 lah. Okay, 4 point. Lastly, turning point, right? So the turning point is what? Add up the two x-intercept. Okay, so turning point x comma y. So add up the two x-intercept and then divide by 2 lah, right? So this is just 7 over 2. Okay, so the y part here is 7 over 2. And what about, I mean, the x part is 7 over 2. What about the y part? So y part is just sub x equals to 7 over 2 into equation. What equation? The graphic, I mean, the curve equation, lah, right? So y equals to 7 over 2 minus 4 times 7 over 2 minus 3. Okay, so this one will be, it's just 3.5 minus 4 and then 3.5 minus 3. Okay, so this is negative 1 over 4. Okay, so my turning point is negative 1 over 4. Okay, so 7 over 2 comma negative 1 over 4. All right, so now can draw already. So x-axis, y-axis. Okay, so you see, smiley face, right? X-intercept positive, so that means it will be somewhere along here, right? Y-intercept positive, so somewhere along here. And then my turning point is underneath here. Okay, so if you see like this, can actually can see how the graph roughly look like already. How come, how come my turning point below? Because my x part is positive, right? Which is here. And then my y part is negative, which is here, right? So it must be here. Okay, so with this information now, I can draw a curve. So how does the curve look like? Like that, lor. Something like that. Okay, so this one is 12. This one is 3, and this one is 4. Obviously, cannot be 4, comes before 3, right? Then the turning point here is so this is 7 over 2, which is the same as 3.5. And then here is what? Negative 1 over 4. Okay, so 7 over 2, comma, negative 1 over 4. Okay, so backtrack again. Smiley face, okay. X-intercept 3 and 4, okay. Y-intercept 12, fine. And then turning point, label 7 over 2, comma, negative 1 over 4. Okay, so lastly, just finalize your answer by labeling the graph. That's all. Okay, Ken, I hope you will understand how I, come out with all this information and then sketch the graph appropriately. All right, so this is it for question 7. Okay, let's go through question 8. Officially, it's going to be my last graph that I'm going to sketch. All right, and then it's what? Sketching from the completed square form lah. Right, so 8 part 1. Okay, let's start off with 8 part 1. Okay, so 8 part 1, so y equals to negative x squared plus 5x minus 4. Okay, so we have to what? Do completed square form for part 1, right? So y equals to, so first thing, factorize out negative, right? So negative bracket x squared minus 5x plus 4. Okay, and then after that, then you got to add in your b square. So 5x plus, okay, let me put a square bracket here, plus 5 over 2 square plus 4, then minus 5 over 2 square. Okay, so this part is where you complete the square. So negative bracket, and then this is x minus 5 over 2 square. Okay, then the rest behind is just press the calculator lah. Very easy. So 4 minus 5 over 2, the whole thing square. And that will give me minus 9 over 4. Okay, so y equals to negative bracket x minus 5 over 2 square plus 9 over 4. Okay, so this is for A part 1. Now, let's go on to A part 2. So A part 2, let's do it in orange lah. Okay, so sketch lah. Oh, so usual lah, sketch. So first thing first, smiley or set. So in this case, it's set lah, right? Outcome coefficient of x square is -1, so set face. Info 2, x-intercept. You see, I've been repeating all this. It's the same, whether be it a factorized form, whether you sketch using a factorized form or you sketch using completed square form. It's the same set of information that you need, right? So x-intercept sub y equals to 0. All right, so negative x minus 5 over 2 square plus 9 over 4 equals to 0. So x minus 5 over 2 square is equals to 9 over 4. Right, so x minus 5 over 2 equals to plus minus square root 9 over 4. This is actually what? 3 over 2 lah. So x equals to 5 over 2 plus 3 over 2, right? Or x equals to 5 over 2 minus 3 over 2, right? This is 1. Okay, and this is 6 through 3. Yeah. Okay, so 3 and 1. Very easy. Okay, that's our x-intercept. And then third point, I got no space soon. Third point, y-intercept on top here, y-intercept. So sub x equals to 0 lor. So y equals to negative bracket 0 minus 5 over 2 square plus 9 over 4. So because I'm lazy, I will just use my calculator. Eh? -4. Okay, did I press wrongly? I'm now very sleepy, so I very scared. Wait, let me just press it. Yeah, -4. Okay, can. Then the last one, fourth, turning point. Oh yeah, so moral of story, don't do math when you're tired. You should take a nap first before you do math. Or for exam purposes, right, you should really sleep early before the test, right? So anyway, turning point, right? So from the completed square form, right, we have 5 over 2, comma, 9 over 4. All right, so with this, can sketch liao lor. So, right, y-axis, x-axis. So first thing, set face, all right, set face. Second thing, x-intercept is 3 and 1, so it's going to be here. Set face, and it's going to be here. Going to cut the x-axis here, right? Then number 3, y-intercept is -4, so my y-intercept is here. Okay, so as you can see, right, it's coming to life already, right? And then after that, turning point is here. So that means my graph is going to look like that. Okay, so let me erase all those, and then it's just going to look like that. Okay, so this and this, so this is what, 1, 3, and then this one is what, -4. Turning point, 5 over 2, comma, 9 over 4. So this is 9 over 4. This is 5 over 2, which is like 2.5 lah. Okay, so now check. First thing, set, fine. Second thing, x-intercept 1 and 3. Yes, I have it. Third thing, y-intercept is -4. Okay, last thing, turning point, 5 over 2, comma, 9 over 4. Is it at the correct position? Yes, cos positive x, positive y. All right, so now last thing, label my diagram, and I am done. All right, okay, yes. So this is it for question 8. Sorry, guys, I want to interrupt. Okay, want to add in something. So, just now I calculate the x-intercept, right? It's 3 and 1, right? Actually, it's not 3. Calculation error, it should be 4. Because 5 plus 3 is 8, right? So 8 divided by 2 is 4. So, but anyway, luckily it doesn't change anything other than the graph and the labeling. So yeah, it's not 3, it's 4. So take note, it's not 3, right? 3 is wrong, it is 4. All right, so we just need to change this into 4 and then this into 4. Okay, we did not need to change anything else because we did not find the turning point using the x-intercept. Okay, but this will be a very grave mistake. Okay, anyway, it's a grave mistake right? Because it's a careless mistake. We should not make this kind of mistake All right, so just take note it's supposed to be 4 and not 3. All right, okay, yes, thank you. Okay, everyone, I'll go through question 9. So in November, right, the exchange rate Oh, this is a real world context question based on, quadratic equation lah. So yeah, the exchange rate between the British pound, right, and the USD offered by a money changer was 100 pounds to US X dollars. Okay, so in December, okay, this is in November lah. So in December, the exchange rate, right, became 100 pounds to USD X minus 5. Okay, can. So if you think about it lah, is it more worth it to change? Wait what did he do? Okay, he want to use US dollars to exchange British pounds lah. So that means um it will be better, right? You change it. It will be better if you change it in December, right? Because you are using less USD. Okay, you are using less USD, X minus 5 to change for 100 pounds, right? But in November, you are using X USD to change for 100 pounds. So if you change in December, it's better for you, right? Better for Raju lah, because Raju, right, found out that, for every 650 USD he exchanged, right, he receives 20 pounds more, okay, as compared to if he exchanged in November. All right, so in part one, you must formulate an equation in X lah. Okay, so basically, right, what I will do is I will find out. Okay, so you can find out how much British pound he has if he change in November. Okay, so if you change it in November, right, what happened? For every X USD, right, you get 100 pounds. Okay, so if you change 650, right, it will be 650 over X times 100. Okay, so you will have this amount of pounds, 65,000 over X pounds. Okay, this is in November. But for if you change it in December, right, is what, how much? X minus 5 right? For 100 pounds, right? Okay, so that means if you change 650 USD, it will be 650 over X minus 5 times 100, right? So it's 65,000 over X minus 5. This is in December. All right, so he said that if you change in December, you will get 20 pounds more. Okay, so that means we can say that 65,000 over X minus 5, because the December amount is more, right? So I will minus 20, and then it will be equals to the November amount. Okay, so yeah, part one, they say formulate an equation, right? So actually this is an equation lah, right? Yeah, so this is for part one. Okay. But for part two, right, you have to solve for X lah, because they want us to find the amount of USD Raju would receive if he had exchanged 1,250 pounds in November. So we got to find out what is X first, the exchange rate lah. Okay, so basically, yeah, shift everything. So shift this. Okay, maybe I should write it on the left now lah. Okay, so part two, so I will shift the equation slightly to become this. Okay, then yeah. Then I will make the denominator the same. And then combine them together to become like this. Okay, then after that I will just minus lah. So what is 65,000 times 5? 325,000 equals to 20x bracket x minus 5. So 20x squared minus 100x minus 325,000 equals to 0 lah. Okay, so I can just factorize out 20 and divide over lah. So x squared minus 5x minus 16,250 equals to 0. Okay, so then I will try to solve this quadratic equation. Okay, so I can factorize actually. So x minus 130 and then x plus 125 equals to 0. So x equals to 130 or x equals to x equals to negative 125. So this is rejected lah, because you cannot exchange a negative amount of USD, right? So it's 130. So that means for November, right, what is the rate? It is 100 pounds equals to US 130. Okay, but for December, right, it is 100 pounds is only 125 USD. Okay, so December way better lah, because you use lesser USD to change ma. Okay, so back to the question part two. Hence, find the amount of USD Raju would have received. Okay, would have received if he had exchanged 1,250 pounds in November. Okay, so so he's using pounds, British pounds to exchange to USD. So that means we are going to, and it's in November, right? Okay, so these are, right? So that means, he will get more USD lah, because USD is higher ma, right? So it will be 1,250 pounds over 100 pounds, then times 130, no? Right, so if you were to do this, you do this, then it's just 125 times 13. Oh, crap. Which is 1,625. Right, so he will receive US dollar, $1,625 if he exchanged 1,250 pounds in November. All right, okay, yes, so this is it for question 9. Okay, let's go through question 11. It's about baking cake lah. So Devi uses X gram of sugar to bake one cake. So write down an expression in terms of X for the number of cakes that Devi can bake with 6 kg of sugar. Wow, okay. 6 kg sounds a lot, but I don't know. I never baked cake before. So okay, anyway, so X gram. Oh, okay. So X gram, you can bake one cake. Oh, why? What's happening? Cake. Okay, so X gram, you can bake one cake. Okay, then after that, what did they say? 6 kg, right? Can bake how many cake, right? So 6 kg is actually 6,000 grams. So 6,000 grams, you can bake 6,000 over X times 1. So 6,000 over X amount of cakes. Okay, so this is the answer for part 1. All right. Then for part 2, Siti, another lady lah. So Siti modifies the recipe and increases the amount of sugar used by 10 grams per cake. Oh wow. Okay. So now for Siti, okay, so for Siti is X plus 10 grams. Okay, for one cake. This is for Siti. Okay, wait, this is part 1. This is part 2. Okay, so this is for Siti lah. Okay, yeah, so CT with number of cakes that CT can bake with 6 kg. Okay, so also 6 kg lah, so 6,000 grams. So 6,000 grams, right, can allow you to bake 6,000 over X plus 10 amount of cake. Okay, can. So this is for CT. Right, then part 3, I think I changed the color. So for part 3, I think my laptop is lagging. Anyway, given that Devi baked 3 more cakes than CE. Oh, okay. So Devi bakes 3 more cakes than CE. Oh, okay, okay, understand. Because you have the same amount of sugar, right? But then you use more sugar for CT lah. She used more sugar in one cake. So obviously CT will bake lesser lah, right? So that means Devi baked 3 more, right? So that means this amount is bigger, right? So that means I can say that I use Devi minus CT amount of cake. Right, it will be 3. Okay, so just same thing, make the denominator the same. Wait, did they want me to show that it reduces to that equation? Okay, so I got no choice, but I got to, simplify it to become that lah. So make the denominator the same, right? And then, yeah, just combine the fraction also, and then equals it to 3. Then cross multiply. But first, this one, 6,000x can minus away lah. So you just left with 60,000 at the numerator. Okay, then equals to 3x bracket x plus 10. So 3x square plus 30x minus 60,000 equals to 0. So just simplify it lor, because they want this equation. Right, so x squared plus 10x, factorize out 3 and divide 3 over lah. So minus 20,000 equals to 0. Okay, so this one, wait, just let me see how come this thing is like lagging. Now it's not lagging. Okay, so anyway, equals to 0. Okay, so shown. All right, okay, so that's for part 3. Now let's do part 4 on the left. Okay, so part 4, I think obviously they want us to solve lah. Yeah, solve. Okay, so let me try to see if I can factorize it first. If I'm not able to, then I will have to use quadratic formula lah, which I don't want to because the number is huge. Okay, yes, I have to. So x squared plus minus square root b squared minus 4 times a times c. This is 20k lah, 20,000, right? Over 2 times 1. Okay, so my x, right, will be equals to 1. Okay, you just solve it. So 136.509. So round up, wait, this is what? 3SF lah. 137. Okay, or x equal negative 146.509. So round off negative 147. Okay, so this is rejected. Okay, because yeah, you cannot have a negative amount of cakes, right? Okay, so yes, yeah, solving it is 137. Okay, then part 5. So yes, Davy and City sold all the cakes at $15 each. Find the total amount of money collected from the sale. Okay, sure. So that means Davy is what? How many cakes is it? Oh wait, sorry. X is not the amount of cake. X is the amount of sugar. So anyway, yeah, you have to reject because you can't have a negative amount of sugar, right? So that means they are using 137 grams. Okay, for Debbie actually, she's using 137 grams for one cake. And then for CT is 147 grams for one cake. Okay, so for Debbie, how many cakes she baked? 6,000 over 137, right? This is for Debbie. Plus, now the CT's amount is what? 6,000 over 147. Okay, so this is the total amount of cake, right? And then I times $15. Okay, so I add the total amount of cakes they bake, and then I multiply by $15 because both of them sold the cakes at $15 each. Okay, so let's see. Oh, I think I can't do that. I have to count individually. Because if I were to do this, right, then yeah, I can't do it. Because, okay, anyway, I can't do it like that. Because this one, right, it will be something like 43.79. Okay, then this value here is going to be 40.81. So if I combine these two decimal places, like the decimal behind, right, you can form one cake already, But then again, they don't make, you cannot just mix the two together. All right, so we can't do this. We can't do this. So that means I have to do another way. So 6,000 over 137, right, is equals to 43.79. So that means you only can round down. So only can have 43 cakes. Okay, that is from Debbie. Then for City will be 40 lah, because Debbie baked 3 more ma. So that means it's just 43 plus 40, then you times $15. Okay, so 43 plus 40, then you times 15 lor. So $1,245. Okay, so this is the total amount of money collected from the sale of 83 cakes from both Debbie and City. All right, okay, yes, so this is it for question 11.